Hola, amigos tensores. Good morning, tensor friends. Got another good question here. It has to do with which of these formats for the Christoffel the symbol to use. And I'm basically paraphrasing this. Why can't I just use this, which looks a lot easier than this? Why do I have to use this? You don't. Uh, it depends on what you're doing. As my answer would be, depends on what you're doing, right? Here's an example. Are you using the covariant derivative to solve like a differential geometry, the problem where you're taking the covariant derivative of something and you got a Christoffel symbol? If so, then clearly you don't need to find the metric tensor. You can do it. You could do it the first way that we showed. But are you working in general relativity where you need the metric tensor anyway if you're going to have any hope of solving these field equations? So if you have to find it anyway, why not make your life easier and just use the format? Uh, but you don't have to. You can do this, and I'll show you. It's pretty easy actually. Okay, so let's take a look. All right, so here is the definition of the Christoffel, the symbol. So if you take the derivative of a basis vector with respect to a coordinate, this is the derivative of vector's vector, and we express that as a combination of its components and basis vectors, right? And so this component turned out to be the Christoffel symbols. Now, let's simplify that. So let's flip it over to the other side and multiply both sides by a contravariant basis vector or a dual basis vector, if you will. Okay, so we're multiplying both sides by this contravariant basis vector. Now, what is this? By definition, a covariant basis vector times a contravariant basis vector, or a basis vector times a dual basis vector, depends on what you're studying, is a Kronecker delta, where this is equal to 1 if L equals K. It's equal to 0 if L is not equal to K. So we can put this right back in here, okay? And we get this expression. And you can see here that this K is going to get absorbed. Now, what do professors mean when they say that? They're saying what I just said, that if L is not equal to K, this is 0. So we got nothing to work with. So L has to equal K, which means that K just goes away and L moves over to here. That's what they mean when they say absorbed, okay? So there it is. So now we have an expression that we can use because the Christoffel symbol is isolated. And notice we have 3 free indexes here, Lij, Lij. There are no summation indexes in here, okay? So let's take an example in polar coordinates, and let's do a quick review. What are the basis vectors in polar coordinates? So we express a position vector as having an x component and the y component and the normal Cartesian basis of vectors. We take the derivative of that position vector with respect to r, excuse me, and we get er. We take the derivative of that position vector with respect to theta, and we get e theta, okay? Now, here's our generalized equation. So this is a non-zero Christoffel symbol that I know of, gamma r theta theta. So L is r, I is theta, j is theta, right? So we need this. So but back on that definition, so ER dot E contravariant R is equal to 1. So what times ER, this is ER, what times ER would equal 1? Well, that's pretty obvious. If we just square both of these, we're going to get 1. So the basis vector ER and the dual basis vector ER are the same thing, okay? So we can put that in. Now we just got to find this derivative. So we put in our E theta basis vector, differentiate it with respect to theta, we get this expression. So we put that back in right there. And we get this. We multiply those together and factor out a minus r, and we get this identity, which is just 1. So the answer is negative r, okay? So it does work. And It's really not that hard to do on these simple systems. If you wanted to do the other one I know is non-zero, which is gamma theta r theta, you just got to find this. So you would use that same definition and say what times this plus what times that will give me 1. Well, you can see it'd be 1 over r sine theta. So that's going to give, cancel out the r's, going to give sine squared theta plus cosine squared theta. And the answer to this is 1 over r, by the way. So it depends on what you're doing. I mean, it's if all you need is this because you're solving a mathematics equation, because Christoffel symbols are used in other things besides general relativity. So if you're just looking for this, you're right. You don't need the tensor. It's just extra work. But if you step this up to space-time coordinates, which is 4 dimensions, and try to solve this equation, I think you're going to find it challenging. I've never done that, but I think you're going to find it challenging. It may be just as easy to use this. Anyway, I hope that answers your questions. I wanted to say one thing about the questions. I really like you guys sending me questions. It keeps me on my toes because usually they're really hard. And if you're uncomfortable in putting a question down in the format like the comment section, then use my email. Okay, and I'll show you how to do that right now. I'm sure you know this, but just in case, you go to my channel. See right here, it says more, boom, view email address. You can send me an email. I do get emails on questions. Some people aren't comfortable in putting things in the comment section. I know I've done it myself to other people. All right, let's get back to our problem.